Hello everyone, this is Kannan Seri. So in this video, we are going to solve the lead code number 33. The question is search in rotated shorted array. So basically, they are given an integer array. So and integer in a shorted array, just nothing but in ascending order. Okay. So I have to find the uh, target element in this entire array after the rotation. Okay, this is the question given. So which means let's take example number one. They are given a array with variable num, and they are given a target value is 0. So we got to find this 0 after this rotation. Okay. So basically, what we are going to do here is first they are given a number in a ascending order. Okay. So this is the ascending order of uh, uh, integer 0 to 7. Okay. So after that we have to rotate the rotate uh, uh, I mean rotate we have to rotate the first uh, three value into last, which means left rotation. Okay, so that's what the question is given in that problem. So given an array after the possible rotation and integer and return the number of integers, so write them must be basically uh, they are given an array. We have to rotate the array in a left. Okay, left shift, which means okay, left shift we have to do. So if the array is that was the question is given. Okay, so after this array rotation, we have to find the target element in the index of the target element. So here the index is nothing but index is here the target element is 0. So the index is nothing but it's 0, 1, 2, 3, 4. Okay. So this is what the questions is what we got to find. So here we can easily find this problem. Basically, they didn't give a rotation, how many rotation or how many values should be rotation. Nothing is given in the question. Actually, the question may be error or question not much tricky. Okay, don't think it's a complex question. It's more tricky question. Don't think like that. Okay, the question is in the medium segment, but it's not much not much tough. Okay, actually they didn't give any rotation value or any uh, uh, rotation numbers. Okay, they didn't give any rotation numbers. They they only give the array and the target element. So usually what we do, to find the elements in the array, what we do, we do linear search, right? So the same thing we will do this in this uh, uh, we will do this problem. Okay, let's try to do this. I already solved this problem. I just try to explain. Uh, it's working in a 0 milliseconds time complexity. Okay, so I just write the code. Okay, linear search code. Parallelly, you can also write the code uh, in a leet code. Okay, so first we initialize in the for loop. So and the for loop iteration should be happen 0 to num size. Num size is nothing but it's a total entire array length size, and the target element is which is they given. So we got to find whether the target element is in the nums of I means nothing but iteration. Okay, equal to target. We have to then we give the return. Okay, so if num of I equal to target means we can directly return the index index. Okay, so this is the program. Okay, this is how this program works. Actually, it's a linear search. Okay, don't confuse this. It's a little basic linear search. Sorry. Um, yeah, actually, so when the target value is available inside the inside the array means it return the value, right? If not, if the target value is not present in the array means what will happen? Basically they are given an integer function, right? Int function, right? If it's given a void function, we don't need to return anything. Okay, so if the int function they are given means we have to return whether the if condition is not satisfied. So actually they are given a problem based upon this. There is a they are given a target value 3. So 3 is not present inside this num value. So they return minus 1 as the output. Okay, so we just write this in, we just return minus 1 if not present. Okay, so if the value is present inside the num means it returns the it returns the index of that target value. So if not means if the entire loop is completed and the value is not present in inside the array means directly return the minus 1. Okay, so I think it's gonna be what? Okay, don't worry. Yeah, it's off. Okay. I just submit this program. Okay, already. Uh, yeah. So actually, this problem they given in this lead code is in the medium tag. Okay, medium segment. Actually, this problem is not much tough or not much not sufficient to. I mean, not much sufficient to tricks problem to. Sorry. This problem is not much tricky. Okay, actually, it's very easy. So, the question is they given in the search and sorted rotated array. They didn't give any rotation. They didn't give any rotation values and how many rotation. Nothing they provide in the question. Okay, so just they give the array and the target value. Find the index position. That's it. Okay, so we are using the linear system directly in this code. Okay, so and also you can be able to see it is the 0 milliseconds. Okay, the code solution is much efficient. Okay, that's the that's the insights we can able to see in the output stage. So we'll just for the 1 millisecond. Okay, they are using a binary search. Okay, binary search method to find. But actually, linear search is works efficiently here. Okay, we not only to look into the binary search, and apart from all the solutions are using the binary search method. Okay, uh, something they are using binary search only. Okay, but we can solve this in the linear search method. Okay, it's very easy. So question they are given in a medium time, but it's not much tricky. Okay, so and then another problem I see in this search and rotated sorted array. It's search and rotated sorted array part 2. Okay, so I don't know why they are given this part 2 program. Okay, actually, what they given is the same thing. Okay, they this question is also a similar kind of question which we discussed in the previous problem. Basically, both are same. Okay, actually, the only difference is here the duplicate values are occurs, but there is nothing duplicate values will occur in the previous question. But we can solve this question by using the linear search. Okay, don't confuse it. Okay, it's not much a tricky question. Okay, we can solve this question in very linear search method. It's some problems looks very tricky, but actually it's not like that. Okay, so that's the one of the example of this problem is right now we are solving this problem. So this problem looks very tricky. Okay, you can able to see when my n plus 1, k plus 1, n minus 1, 0, 1, 2, and a lot of problems see it's look like a very confusing problem, but actually it's not like that. Okay, we are used directly giving the linear search to solve this problem. This is the uh, this is the way, it's a kind of way of approaching the problem. Okay, so if nums of I equal to target return true, or we can give return 1 0. Okay, boolean function, right? If we give 1 means it return the it return true. If we give the 0 means it return the false. Okay, I'm giving true and false. Okay, let's see if you understand. Yeah, the same kind of problem. Okay, I think it's gonna work. Okay, don't worry about this. Yeah, so I just submit this program. Already completed this program. I just try to explain this program to you, and you can able to see uh, it is the lowest time complexity and space complexity program in that entire lead code solutions. So as you can able to see, so the solution is 96.56% of solution uses 0 millisecond. So our program runs in the 0 millisecond runtime. Okay, so and 1 millisecond they are using binary search. Okay, not much tricky. Okay, So we can solve this in a linear search method. This is one of the easy program. Uh, um, if you're interested means you can try to solve this program. Okay, it's easy. Okay, so don't look the questions way of questions and we are asking the question. Just look into the test case and how to solve this test case in a different approach. One of the approaches linear search we can solve it is in the binary search, but the length of the code is very high, and also code is efficient is also high. Uh, yeah, okay, fine. This linear search is much good. Okay, thanks for watching this video. Let me see in the upcoming video.